Now, as we have configured the Cloudsim source code as a project in Eclipse, let us first explore the structure of the simulation project. Your Eclipse project explorer should be containing 6 folders and 7 files. The readme.txt file contains the basic information about the project, like how to install and run the Cloudsim, what is the basic directory structure. If you are not using any IDE, then how to build the project source code. So it's a very comprehensive detail corresponding to the Cloudsim project. Now let us look at the directory structure in detail and understand the various namespaces available in source folder. There exist 12 namespaces. Each namespace has set of classes with a specific correlated function. Let's go in detail on org.cloudburst.cloudsim. Now this particular namespace contains variety of different model classes of various basic hardware components, their groups, and the allocation utilization methods. Here model means that classes contains the implementation of the various attributes and behaviors of the real-life cloud computing hardware setups as a collection of Java methods. Once these classes are instantiated during the simulation, they are going to simulate the behavior of the real-life cloud-based system components. Let's take an example. So as we know, every cloud computing system is based on the data center deployments. Now every data center contains host, and each host is actually containing certain set of VMs. If you go and look into the host.java class, in this you will be able to find that there have been various kind of attributes which are used by these hosts. Like every host has a processing element. There may be one single processor or maybe multiple processors, right? So that is contained in a PE list. Similarly, it also has a set of storage. So that is contained in this particular attribute named as storage, which is of long type. Similarly, some kind of scheduler is there. There are certain set of VMs which are supposed to be hosted over that. There is certain bandwidth that is to be used by the host. So these are certain attributes. Now these attributes are supposed to be updated, or the value is supposed to be fast at various intervals of simulation process. So if you see, we have various get and set methods, and apart from that, because these hosts actually contain a set of VMs which are allocated with the hardware resources of the host, so we also have an update method corresponding to virtual machines processing. Virtual machines can be created, can be deallocated, can be destroyed, and so on. So all those behaviors are being implemented here. Similarly, let's take another example, that is virtual machine. Now we know that virtual machine behaves as a virtual hardware component, right? So they must also contain the similar set of implementation as the host have, but they might also contain certain more attributes, because VMs are actually going to contain the operating system, and they are going to execute the tasks which are being allocated by certain user load, right? So if we look at the attributes, what we see is how many number of processing elements are to be allocated from the host, what should be the RAM, what should be the size of the storage, which host it is going to be allocated, right? So all these attributes are provided here. We will be discussing all these classes in detail in the later part of this course. Now let's look at the behavior. So we have certain set of get methods, and similarly we also have certain methods in set instance type. Apart from this, because the VM processing is to be done, so update VM processing behavior is also being generated here, right? So that method is also available as similar to the host. Now the difference here is this update VM processing is only for the virtual machine which is going to be executed on a host, whereas update VM processing which is on the host machine is going to generate a behavior where it is going to do the updation for all the virtual machines. So in turn, this method is going to call the update VM method from the VM class. So there is a correlation. So need not to worry about this. We will be discussing about this thing in our course in very much detail when we are going to talk about the migrations and the specific selections and allocation policies. So overall, right now the core model classes which are being available in this org.cloudbus.cloudsim package, they are the one who are actually going to support the simulation process by building up the behavioral factor of the real world cloud components. So if they doesn't exist here, your simulation cannot be worked out. So these are some of the classes which everyone should give certain attention before they actually go and start working upon the simulation, actual simulation of their research scenarios. Now let's look at the second namespace, which is org.cloudbus.cloudsim.core. Now this particular namespace contains the implementation of this actual simulation engine, where the cloudsim.java class is responsible for the start and stop of the simulation process, which actually generates the complete scenario for the workload execution. Now here, one of the most important class is the sim entity class. Now this sim entity class is basically used to maintain the state of the cloud computing components which are being initiated during the simulation process. So when I say entities are data center broker, cloud information systems services, and so on. And because this is a simulation process, so there are a series of events which are going to happen, and you need to log all those series of events as a part of a queue. So what we have is, we have two classes given here. One is the sim event class, and another two set of classes is the future queue as well as the deferred queue. Now they are responsible for maintaining the queue to have the inter entity related cloud function calls, and they are the most important one. So overall, the complete simulation requires all these set of classes, otherwise the simulation process cannot happen. So you need to log the events, you have to maintain a series of queues, and once these queues are being populated, the simulation engine starts working around the workload execution. Once these queues are empty, that means the overall workload execution is being done, and this is going to lead toward the stop of the simulation. So there are around 8 classes which are very important. If you understand them, this is going to give you a very good insight on the overall behavior of the simulation engine. Now next, org.cloudbus.cloudsim.core.predicate contains the classes related to the selection of events from the deferred queue. So that means it is a support namespace for the deferred queue.java class. Now this particular predicate set is used during the simulation event processing. It's a very important thing, because until unless the deferred queue is not empty, the simulation cannot be stopped. And deferred queue is used for various different factors. Like if I give you one example, whenever a cloudlet, which is commonly named as task, is being paused, instead of sending it back to the data center broker, this particular task will be scheduled in the deferred queue. Right, so anything which has been paused will be sent to the deferred queue, so that later on, whenever the system is free, it can execute it. So that is the importance of this particular namespace. Now the next namespace we have here is the org.cloudbus.cloudsim.distribution. Now it contains the implementation of various distribution functions, but is not at all used anywhere in the Cloudsim till date. They are just given as a generic part. They might have kept it for the future purpose. Now next set of namespace what we get is org.cloudbus.cloudsim.list. Now this contains the implementation of list to be used globally during the simulation processing. These are the specialized set of classes where sorting and comparison operations are implemented. Just like list of host, list of processing elements, cloudlets, VMs, and resources, they all are being implemented here, and these are one of the best classes which we can use for comparison purposes as well. So they are quite important and interesting one. Next one is org.cloudbus.cloudsim.network. Now this contains the implementation for the network simulation purpose, and it is the best place if you are looking for implementing your research work, which is based on network optimization techniques. So if you look at the set of classes, what we get is topological graphs, topological links, topological nodes, graph readers, specifically this bright based topology which has been implemented as a default in Cloudsim, and that is what you get. The next namespace which we get is org.cloudbus.cloudsim.network.datacenter. This namespace contains the extended implementation of the basic cloud hardware component, which can support the federated cloud function distributed across the regions. So we can actually simulate a lot of different scenarios where we may generate data centers which may belong to different region, and then we can see that what sort of network delays and all that stuff happens. So we can have edge switches, we can have host packet which are being sent, we can have certain kind of network based cloudlets where a workload can be distributed across the different set of data centers, and then later on it can be brought back to one single data center broker, and then the whole data can be compiled for the output process. So this is the beauty of this particular namespace. Next comes is the org.cloudbus.cloudsim.power. Now this is one of the very important and the most used namespace in Cloudsim. Now this package contains the extended implementation of cloud components which can simulate the green or power aware computing scenarios. This namespace implements the VM migration related classes where an extensive algorithm codes are available for VM selection and allocation related to the migration. And it's really easy and simple to understand it. So if you look at the set of the classes which are here, you will see the power data center .java class, then you have a broker class, then you have a non-power aware Java class as well, you have a power host. So all these classes contain some logic relevant to calculation of the power consumption. Now apart from this, if you look at the set of classes which are for the allocation, they are the implementation of the different generic algorithms which are being available, specifically this migration regarding by using local regression, then migration by using static threshold, or maybe by using interquartile range. Similarly, before allocation you actually have to do selection, so you have maximum correlation, minimum migration time, and so on. So all these algorithms are pre-handedly coded within your Cloudsim setup 3.0.3. and you can actually utilize them with certain modification and do your research scenarios here. Now to support this, what further set of namespaces, sub namespaces are given, that is the list which actually contains the power VM list, and this is the extended version of the VM list which we actually looked into this org.cloudbus.cloudsim.list namespace, right? So this is what I'm talking about, vmlist.java. Now let's look at the another one, that is org.cloudbus.cloudsim.power.models. Now when you look into this, what it gives you is, it gives you the standard models of power which are being used by existing brands, right? So this particular namespace actually contains this set of classes which specifies the power configuration of servers as a model class. Now these classes basically imitate the actual working of the various server machine brands which are available in market, and helps in determining the power consumption by such machines during a particular simulation environment. So maybe you wanted to run your research based solution within the Cloudsim, and you wanted to test it corresponding to one particular brand model. So let's say if we talk about this IBM X3250 Xeon system, so that can be actually worked around. Similarly, the next namespace that we have is org.cloudbus.cloudsim.provisioners. Now this is one of the namespace which contains the behavioral implementation regarding that how the specified cloud component will be provisioned to the requested resource. So it's more or less related to allocation of the resources to the virtual machines and the relevant stuff. The next one which we have is the org.cloudbus.cloudsim.util. This contains the very simple and basic implementation of the certain mathematical function calculations and is a general utility set. So it's more or less used for the calculation purpose only, and it just work as a support system for the overall calculation mechanism of the simulation process. Now let's look at the another folder, that is examples folder. Now if you see, it contains around 7 different namespaces, and each namespace contains various specific scenarios which are being implemented. Now if I expand this org.cloudbus.cloudsim.example, you see there are 8 different Java files which are numbered from 1 to 8 are being displayed here. Now if you wanted to understand them little bit in detail by yourself, you can just simply go to this examples.txt, and if you see here, it tells you about that how you can run the Cloudsim examples, and what is the basic source, and what way you can run it on Windows or Unix. Now once you go through all these instructions and come to the bottom of this particular file, you will be able to see certain description about the scenarios what these Cloudsim example 1, 2, 3, 4, 5 up to 8 work around. So if you see here what it says, Cloudsim example 1.java generates a scenario where you create a data center with one host and run one cloudlet on it, right? So cloudlet means here is task which has been given by the data center broker. Now next one is, if you look at the Cloudsim example 2.java, it shows how to create a data center with one host and run 2 cloudlets on it. The cloudlets run in the virtual machines with the same MIPS requirement. The cloudlets will take the same time to complete the execution. So this actually gives you an insight that what sort of scenario these examples have given. Not to worry if you are not able to understand it. We will be looking into these examples in detail in further videos. So just to have an understanding that the Java file in this examples namespace, what you get is the general scenario implementation. So the very first namespace, that is org.cloudbus.cloudsim.example, contains a very basic scenario implementation, whereas further two namespaces contain the network based implementations, and then further 3, that is power based example implementation, where you are able to see that okay, what are the different set of selection and allocation of virtual machines are being used, what are the different algorithms used, and what are the different combinations that they have. So this is something which is quite relevant to understand that how this whole scenario of cloud based system works around either the non-power aware or the power aware part. Now one of the most important thing that you should always give attention to is the workload.planetlab. Now this is one section of the Cloudsim which is generally being used for the benchmarking purpose. This particular data set is being collected from the Planetlab, and that actually ran a real life scenario of the workloads. And what does this data set contains? This data set contains a set of CPU utilization traces from the Planetlab virtual machines, which was collected like randomly during the 10 days period of time. And it was done during March and April month of 2011. This is what we have corresponding to these two folders, and these are the main folders of your Cloudsim project. Now apart from this, there are another set of folders and files which are available. Let's discuss them. The very first folder which you generally see is the JRE system library. Now what I'm using is my version installed on this particular Windows machine is JRE 1.8.0, and the version they have given is 2.11. So this folder is automatically created during the build process of the Cloudsim. Now next folder which we have is the reference libraries. Now these reference libraries are again being added by the Eclipse itself, and it contains the various dependency jars which are automatically added to the project by the Eclipse. Now another folder what we have is the docs. Now this docs folder contains the minimalist documentation of Cloudsim class API and is automatically generated from the inline comment by the project owner itself, and it is being supplied with the source code. So that is what we have. And it's a very minimalistic. You can actually go and see what sort of different methods are there, what exactly they take as a parameter input, or what parameters they give as output, but not much detail. So you actually need to go and drill down into the code to understand that what exactly it does and what sort of calculation it performs. Now the next thing what we have is the jar folder. Now this jar folders is again supplied with the source code, and it contains the pre-compiled build of the Cloudsim 3.0.3. This can be used for creating the custom project scenarios whenever required. So we will be working on one of the scenarios in the later part of this particular course, and that will be very detailed one, that how we can build up your complete Cloudsim based scenario from scratch and how it can be deployed. So that is what we have planned for this particular course. Now apart from this, what we get is certain set of files. So if you look at build.xml, this is an ANT based XML file which is used during the console based build processes. As we are using Eclipse, so it is no use for us. Next is the changelog.txt. Now changelog.txt contains the history of the changes which has been done on the Cloudsim project, and whatever it has been released under various versions. So you will be able to see a complete changelog, that okay, which version was released, what were the changes which have been done, what bugs were being fixed, and so on. Next one what we get is examples we have already seen. The licenses.txt contains the general notification of GNU GPL as this Cloudsim source code has been released under this particular license. Now next one is pom.xml. Now this pom.xml we have used during our first video, where we have configured our Cloudsim in Eclipse, right? So this has been used, this is a Maven configuration file which is being used for the setting up of the system. So we can actually go and look into the details, that what sort of different issue management or integrations, or what versions does it require, right? So what dependencies does it require, what dependency hierarchy it might have, or maybe you can actually go and directly look into the pom.xml file to get into the details of what configuration does it contain. Now readme.txt we have already gone through, and finally we got as the release _notes.txt. Now this file contains the note from the Cloudsim development team, and it gives you a basic understanding about that how this project works around, where the code has been put, what is the way they do the issue tracking and all, and correspondingly they give you the link to the website, and they also tell you about the licensing and all that stuff. So this is what your Cloudsim basic project structure is, and what are the different files they have, what are the different namespaces they have, and what sort of information does they contain. So with this we stop this particular video.